Hello, in this video I'm going to give a little bit of background to Johannes Kepler, a very interesting character in a very interesting time in the history of science. So let's do a quick recap of this timeline of science and the birth of science before I get onto the details of Kepler's life. So we've discussed this before. We're talking about this transition from natural philosophy, where we don't have science as we think about it nowadays. So Aristotle is probably the main name that we're going to attach to natural philosophy. So Aristotle, he was describing the universe, which of course is what we're aiming to do in science, but he was doing it in more the style of an armchair philosopher than an actual scientist conducting experiments. He wasn't engaging in the scientific method, conducting experiments in order to test hypotheses and theories and such like. So he was more putting together what he saw as being an intellectually coherent view of the universe without conducting experiments. And we want to get to science as we know it nowadays. So we want to get to science where we might be looking at, well, let's take Newton. He'd be a good name to usher in the new, what we describe as being science. Obviously, he isn't the only person. There are loads and loads of people. But you could say by the time we get to Newton, the lingering natural philosophy ideas were very much out or on the way out by the time we've got to Newton. So here we're looking at coming up to, well, before we get to 1700, but let's say 1650 to 1700, it feels as though we're really getting into science. Newton was conducting experiments, as others were, but he just happens to be a big name. The transition from Aristotle to Newton was not just a straight dividing line. Sometimes you can get an impression in summaries of what's happening that you get someone like Copernicus coming along. So Copernicus, we're looking at around about, say, 1500. That's about the middle of his life. And all of a sudden, he's taking Earth away from being the centre of the universe, and everyone throws off their religious superstitions and ditches Aristotle and moves into a new world of science. Well, that isn't how things were. There was a transition period of 100, 200 years, give or take. I mean, these dates are all a little bit movable. There's no fixed date when all these things happen. But you've got a transition period, and we can see here Kepler is sat well and truly in this transition period. He's about 100 years later than Copernicus, and he's 50 years, a little bit more, 50 to 100 years before Newton. So he sat in this transition period between Copernicus and Newton, along with other people like Galileo. And you get this weird mix of the actual practices and the science and the maths and the natural philosophy that they were doing. There's still a lot of superstition there. There's still a lot of astrology, which of course we now know isn't scientific, but they did a lot of astrology back then. I mean, even Newton did alchemy. So you've got alchemy, you've got astrology, you've got these things. A lot of their investigations were driven by religious convictions. Kepler was a very religious man, and his drive for scientific understanding was driven by this idea that, oh, well, God has created the universe and the earth and everything else in the universe. God has created it in a way that is intelligible to man and can be described by man, and by describing the universe in that way, it takes you closer to God. So there was a lot of religion still in science. There was a lot of the natural philosophy there. So it's this transition period, and I think this is worth stressing at the outset, because it might appear when I go through the descriptions of the sort of things Kepler was doing that you think, yeah, this guy wasn't really a scientist in a lot of his practices. So that's why I'm setting this context at the beginning. Right, so let's get on to Kepler's life then. So he's a German astronomer, mathematician, writer. He was born near to Stuttgart, which is now southwest Germany. So that's where he was born. Turbulent times here. I mean, we're looking at 50 years or so after a little bit more after the Reformation. So you've got a lot of religious issues throughout Europe. You've got a lot of wars going on. I mean, it was believed that his father was killed in the 80 Years' War. His mother was a herbalist and a healer. So you've got a lot of unusual things going on compared to what we'd expect nowadays. It was very, very turbulent times. There was a lot of disease about. Kepler himself, he contracted smallpox when he was a child. It weakened his hands, it weakened his eyesight, which is a problem for someone who was going on to deal with observational astronomy. So, not everything was in his favour. He wasn't from a particularly wealthy family. The understanding is that they had been a bit more well-to-do in the past, but they had fallen upon hard times by the time it had got to Kepler's generation. But he still had more than most. He was still educated. A lot of people weren't. He went off to a university. He studied some philosophy and theology, but this would include things like maths inside the philosophy, and he was exceptional at maths. I mean, this was apparent from an early age. And he had this reputation as a mathematician. He had this reputation as an astrologer. So he was constructing astrological predictions and forecasts for people while he was at university, and he got a reputation for this. And he wanted to become a Lutheran minister. So, as I say, this was not long after the Reformation. So Lutherans, one of the main Protestant branches at the time, and well, still is, and he was a Lutheran, but his beliefs were not entirely consistent with the statement of faith for Lutherans. So he was a bit on the fringes of being a Lutheran, and this would cause later problems in his life as well. So without being able to become a Lutheran minister, he became a teacher instead. He became a teacher of maths and astronomy, and he moved to Austria, to Graz in Austria. And it was at this time he married. He published a book on astrology. That was where he started out. And he started corresponding with Tycho Brahe, who I've mentioned in previous videos. So Tycho, the crater Tycho on the moon, is named after him. He's the one who famously ended up with a prosthetic nose because he had his nose cut off in a duel. And he started corresponding with Brahe, and they were discussing theological issues, as people did at the time, and the theological issues and problems with various astronomical theories. And it was not possible to really separate these things at the time. Astronomy and theology were hand in hand. There was this separation between the earth and the world, the realm of people. So you had humans on earth, and you had the heavens, which was associated with God. And the heavens were seen as being unchanging. People were seeing the same stars in the sky each night. Okay, it would change throughout the year, but the stars were constant. Things changed on Earth. It was seen that, that physics, okay, they hadn't actually coined that as an idea at the time, but physics, as we would describe it nowadays, they thought was concerned with what happened on Earth. It was describing how things were changing to a large extent. Whereas the heavens, which they thought were to do with an unchanging God, were separate from that. So there was a lot of interaction there between what was going on in the heavens was meant to be in some way reflective of God. So a lot of the theories in natural philosophy that Aristotle would come up with, they were to do with various spheres, so with the Earth at the centre, and you'd have these spheres that were shells around the Earth, that perfect spheres that moved in certain perfect ways. And this is how the universe was being described. So Kepler was discussing all of this stuff with Brahe, and he realized that he couldn't answer a lot of these questions because the data that they had, the observational data of the stars, of the planets, wasn't accurate enough. So this was already setting him off on a path of wanting to get more accurate data so he could answer these theological questions. He subsequently moved to Prague, which is where Tycho Brahe was, and he had problems. He didn't just move there because of that. He was having problems back in Austria because he was not converting to Catholicism. He didn't want to be a Catholic, so a combination of the two, doing a runner to get away from the religious issues and going to work with Brahe in Prague combined, and he went over there. This was around about 1600 or late 1590s. Brahe suddenly died in 1601, and then Kepler took over his role. So Brahe was the imperial mathematician to the Holy Roman Emperor at the time. So at the time, that was Rudolf II. I mean, he was Holy Roman Empire. He was king of various places, Hungary and Bavaria and things like that. He was one of the Habsburgs, who had pretty much ruled everything back in the day. And he had an imperial court of advisors and such like, and Kepler took over as the imperial mathematician, although his main role was to create horoscopes for the emperor. So the emperor was using these horoscopes, not to see how he was going to be feeling that day, but how he should conduct his political machinations and such like, and negotiations around Europe, and how he should manage his affairs. So Kepler was mostly doing that, but he had time and now a bit more money in order to pursue other things. Now, in 1604, there was a supernova, quite a bright one that people were observing, and Kepler observed this supernova in considerable detail. And this caused issues. Supernovas were a problem for astronomers back then because, as I've already said, they saw the heavens as being something that was unchanging, reflective of an unchanging God. Then you suddenly get a supernova and a new star has appeared. This causes a few issues from a theological point of view, and it's another mark against Aristotle. So we had that going on. So this was moving him more into taking another step towards what we'd see as science and away from natural philosophy. So that supernova had quite an impact. But there were still tough times when he was dealing with all of this. There was more poverty. He was doing a bit better than he was when he was in Austria, but he still wasn't great. There was more sickness. His wife died, one of his children died. He was now getting aggro from the Lutherans as well as the Catholics because he wasn't seen as being Lutheran enough. His mother was accused of witchcraft. So again, this was by the Protestants, so he was getting attacked from a religious point of view from both sides. So he wasn't having the greatest time of it all. But he did manage to publish his first and second laws of planetary motion in 1609 when he was in Prague as part of the imperial court. The third law, he published that about 10 years later. It took him a bit longer to figure that one out. And that was after he'd moved back to Austria. He'd left Prague. Rudolf, the Holy Roman Emperor, he had died. And I think his brother had taken over. And Kepler was allowed to go back to Austria. And he was making all of these detailed astronomical observations. And alongside that, he was also working on optics as well. Because all of this he needed the observations in order to come up with his laws of planetary motion. He was trying to map out how these planets were moving. And again, this was a big step against the church and the religious views of the time. As I say, they were previously thinking in Aristotelian ways of perfect spheres in the heavens. Think of Kepler's laws. We're now moving to an ellipse, not a circular path on a sphere, but planets moving in ellipses. These aren't perfect circles. So what is that saying about your theology and such like? So he's walking on some dodgy ground there with some of this stuff. And this was all based on his detailed observations that he was making of planets. Well, and other people were making as well. He was working with Brahe back in the day. So he was doing that, and he was doing alongside work on optics. He'd come up with a new and improved version of the refracting telescope. Galileo had come up with his telescope in about 1610. Galileo was getting some great observations with his telescope. Kepler came up with something better, and he published what is now seen as being the first major work of modern optics, when he did a book on parallax, on reflection from flat mirrors, concave mirrors, convex mirrors, how pinhole cameras work, the inverse square law of light intensity. So he did this whole book on optics as well. So he was covering a lot of stuff there. He also worked on other things. He did a paper on snowflakes, looking at the symmetry of snowflakes and then conjecturing about how what we'd now describe as atoms and molecules, but he didn't know about those terms back then, but how the constituent elements of snowflakes would be packed in various ways. The different atomic packing arrangements that you cover in A-level chemistry nowadays. So he was conjecturing on those sort of things. So he was covering a lot of areas. But as I say, we mainly remember him now, particularly in physics, for his laws of planetary motion. But a lot of people didn't accept those at the time for those theological reasons, for this things like moving to an ellipse rather than having these spheres. So he was talking about the planets themselves actually moving, not a planet being attached to a sphere and that sphere moving. So he was coming up with the idea of an orbit and these planets actually moving and moving independently to some extent. So this was all new stuff that was challenging really deep ideas, deep-rooted ideas at the time. So a lot of people just rejected this. Galileo wasn't a big fan. Descartes wasn't a big fan. It was quite ahead of his time in what he was coming up with in these theories. But it did influence greatly people like Newton, who were just that little bit further removed in time. These people coming before him had done a lot of the work, had set the scene for these discussions, dealt with a lot of the religious issues. I mean, Galileo, he really had it in the neck on a religious point of view. So a lot of that had to get dealt with from a cultural point of view before the likes of Newton could really take that next big step into science as we see it nowadays. So this is what makes Kepler so interesting. He really does sit on that boundary between natural philosophy and science, between religion and other things that nowadays we'd see as being superstition, things like astrology. He's sitting on that boundary between religion, astrology, superstition, and astrophysics and science and the scientific method. So he's really there at that transition where people were literally putting their reputation, lives, and everything else on the line and conducting these experiments in very, very difficult conditions, without much money, with a lot of disease, with war, with turmoil. So yeah, amazing chap, as a lot of them were at the time, for what he managed to achieve in those circumstances. So there you go. That's a flavour of Kepler that goes beyond just looking at a guy behind 3 laws of planetary motion.